Our next speaker is Martin Omander. He's the real Googler. and he will talk you about Firebase and cool backend with it. Let's start.
First off, oh yes, before we do anything else, you are going to help me. Because when I told my manager that I would be going to Minsk and speak at a conference, she said, oh, you're just going there to drink Krynica beer or hang out and party. And I said, no, there's actually a real event there. And she said, yeah, sure, whatever. So we're going to show her. I'm going to take a photo of you, and you're going to wave to my manager. And if you want, so you're going to wave with both hands. And then if you want, you can mime out, please approve Martin's expense report. So I'll start from out here. Please wave to my manager. Yes, very good, very good. I'll take one from over here as well. Let's see, I want to make sure I capture all of you here. Yes, wave to my manager. Please approve Martin's expense report. Yes, very good. Excellent. If that doesn't get my expense report approved, I don't know what will. So we're going to talk about building a backend with 100 lines of Firebase code. And first, here's a picture. This is what I look like when I'm wearing a jacket. My name is Martin Omander, and I was born and raised in Sweden. I've lived the last 19 years in California. And of those I worked at 3 startups over there as a software engineer. And then 12 years ago, I started working at Google. I've had a few different jobs at Google during that time. And my current job is I'm a developer advocate. And there are 2 things you do when you're a developer advocate. One is I'm here telling you guys about excellent Google products that you should use. That's the first job. The second job is that I will talk to you, you will have a chance to tell me about your use and which Google products, which Google developer products you are using and how they work for you. If there's things that are broken, if there are things that could be better, I love to hear that because I take that with me back to California where they were building the products, and I tell them that this is what developers want. So if you're using Google Cloud and you have or Firebase, you have feedback on products, please talk to me afterwards. Also, there will be a survey where you will get a chance to fill it out if you're more comfortable writing it down. So in this talk, we're going to talk about a hypothetical, a fictional startup, and what they're doing and how they build out their backend. So in this fictional startup, we have a developer named Beth. She is starting this company with a mission of bringing joy to the world. She's a developer. She wants to bring joy to the world. How? How will she do that? She has an idea. So she's thinking about my user. You should always do like modeling of your user, thinking about what your user is doing. The use case here for Beth's startup is very simple. We have a user named Alice, and Alice will engage with Beth's service this way. Alice will send a text message to Beth's service, and then Alice will get a joke back. Super simple. So now Beth has to build a backend that supports this. You receive a text message find a random joke in a database of jokes, and send it back to Alice. Now, if you start searching, like Beth here, you start searching for how to build a service that is scalable and always available, can handle a lot of traffic. If you search for that sort of thing on the web, you might find pictures like this. This is a typical backend. This is backend of Wikipedia, actually. So we have databases, and we have load balancers, and we have read-only replicas, and we have lots of stuff. We have lots of arrows. There are 27 boxes here. So Beth thinks to herself, am I going to build out this infrastructure? That will take a year or two. And I haven't even started building my actual service, which is sending jokes to users. Beth is thinking, I need something simpler. I can't build this. So what is there that can be simpler? Well, Beth wants to build her own microservice, have it connect to Twilio. Twilio is an SMS gateway. It's another company. It's not Google, but they're a great company. Has anybody here used Twilio? One? Oh, a few, yeah. Oh, gosh. How has it worked for you? Are you satisfied with it? Or does it work well or not? So-so? So-so. Is it like not reliable, or what's the problem? Oh, not flexible enough. Got it. I see. Yeah. I think Beth has a simpler use case than you do. So it works fine here. But yeah, if you dig into it, I could see how it's very simple. Yeah, not very, you can't do very advanced things with it. So then the question is, this microservice here, what should be in that box? She wants to have one box, not 27 boxes. Well, it turns out that there is a product called Cloud Functions for Firebase that lets you do exactly this. It lets you write your backend in JavaScript, and it scales, it runs on Google servers, so it scales up. If you go from 0 users to 1 million users, it can scale up with you, and it scales down with you. So you pay per invocation of your code, per time. Every time your code runs, or the function is invoked, you pay a little tiny fraction of a cent. So let's look at what the code might look like. Beth wants to create a very first version of a service. First, we just need to import some of the Firebase functions library. We need to import 2 Twilio libraries. And here is the header of the function. It's called reply. The function is called reply. It takes a request and it takes a response parameters here. Beth would create an SMS response, put the joke inside the SMS response, send the SMS response back, and she's done. And she has now created a scalable backend with 1, 2, 3, 4, 5, 6, 7 lines of code. 8 lines of code if you count this. I don't know. Do you? Maybe, maybe not. 7 or 8 lines of code. And she's created a scalable backend. Instead, she doesn't have to build those 27 boxes. Although, I've talked to a few of you before, and there are some really smart people here in the audience. I think you may be able to see what I have left out from the code. What am I missing? Get joke, yes, good job. Yes, so she's calling the get joke function here, which actually picks a random joke. Now that function I haven't defined anywhere. I'm a little ashamed of this code. Okay, don't judge me. This code is not pretty. This is what get joke might look like. The very, very first version of get joke. Can you see where this is going? Yes, it's a very, very simple version. It's not very pretty, but here's a first joke. Here's a second joke. There's a third joke. And those are her jokes. And then we can define getJoke, and we just get a random index here from 0 to 2, and then we return the string at that index. Return one of these 3 jokes. Now, this is not very pretty. Maybe you wouldn't write this in a production system. But the cool thing here is that Beth has now written up something that's like 14 or 15 lines of code, and she has a complete backend, a prototype, an MVP, minimal viable product, that she can show to investors. And it works, and they can send text messages to her number, and they get jokes back. So she shows it to investors. They love it. But they pretty soon discover that there are only 3 jokes in her app. So they say, hey, Beth, you need to put more jokes in your application, in your service. So we're going to give you lots of investor money so you can hire somebody. Great, Beth says. She hires Charles. He's a writer, and he comes up with new jokes. So Charles, he sits right next to Beth at his desk, and he writes a joke. And he's like, oh, this is such a good joke. He goes over to Beth and says, Beth, put this in the JavaScript array. And she writes it into the JavaScript array. She deploys the code. 5 minutes later, Charles has written up a new joke. This is an amazing joke. Beth, look at this. Put this joke in the JavaScript array. And she does it. And then he writes another one, and then he remembers, oh, Beth, that joke we talked about 2 minutes ago, there was a misspelling in that. Can you fix it? And she opens the JavaScript file and fixes it and deploys it. There's a problem here. Beth is inside the deployment loop, deployment of content, right? Not a good place to be for a developer. Content should be handled by others. So Beth says, look, Charles, what if, instead of you telling me about these, what if you just enter them in a Google spreadsheet? By the way, my favorite here is number 10. What's good about Switzerland? I don't know, but the flag is a big plus. Because this is an admin user interface. Very simple one, but it's an admin user interface that Beth doesn't have to write a single line of code to give this to Charles, because it already exists, right? Google Spreadsheets. So what she has to do then, so he can deploy jokes in a spreadsheet, but then we actually have to have code up here that reads from sheets instead of reading from a hard-coded array. So what does that look like? Well, it's a little more code. GetJoke is now an asynchronous function. And first we need to get an auth object. Because we're on the server, we don't have to deal with passwords, OAuth tokens, keys, none of that. This is all you need to do to auth. And then we need to create the API. We need to call the Spreadsheets API, give it a spreadsheet ID, and we need to tell what cells to read. So here we're going to read cells from sheet 1, and we're going to read all the cells in column A. And then, just because we get this back as a 2-dimensional array, we need to make this a 1-dimensional array. And you can do that with a loop, or those of you who are doing modern JavaScript, you see here that this arrow function is a nice way to do that. But basically, from 2-dimensional array down to 1-dimensional array. And then we have our old friend here, find the index, and return the joke at that index. OK, great. So she has created an admin interface for Charles. She didn't have to write any extra code for that. She had to write a little bit of extra code to read jokes from the spreadsheet. Charles, he is great at his job. He comes up with hundreds of jokes. He comes up with thousands of jokes. He comes up with tens of thousands of jokes. Now we're starting to see some problems here. What are some problems we might see with this architecture? Say again? Slow, oh, performance, yeah, that's right. So usually this is super fast, but sometimes this will be a little slow, especially when you have tens of thousands of rows. Because if you remember the code we just looked at, if there are 10,000 jokes in the spreadsheet, the code would read all 10,000, would pick one random joke and return it to the user, and it would throw away the other 9,999 jokes. It's kind of a wasteful algorithm. I mean, it worked great for when there were a few hundred or a few thousand jokes, but we need something more scalable now. Our company's growing. What might we do instead of Google Sheet here? Database, excellent. Good idea. So if you know SQL, you could put Cloud SQL in there. Cloud SQL is MySQL hosted by Google as part of the Google Cloud platform. You can also put a NoSQL database in there. There are a few different ones to choose from in the Google Cloud platform. But Beth has used SQL before, so she's putting a Cloud SQL database in there. Let's see what the code would look like. So let's just go back here. So now it's the code to read from the microservice to read from the database. So it'll be something like this. Get joke, you create a SQL statement. This bit of funny stuff going on here. Order by rand, limit 1. That is a clever SQL way of saying, give me a random record in this table. Very clever. I have not come up with it. I found this on Stack Overflow. And then you just, because it's asynchronous JavaScript, we do some promise stuff, we run the query, we get the result back, return that, and we're done. So it's actually even less code to read from a database here. And we now have a scalable solution here where we have the admin interface here, and then we need to write some code to insert from the spreadsheet into the SQL database. And then we have a very scalable backend here that can handle, hundreds of thousands, possibly millions of records. Okay, great. The investors, they love this. So they tell Beth, look, this is great. You have an amazing service going on. You have a good technical platform. What you need is some analytics. You need to identify which are your repeat users. You need to identify who are the users who come in once only and then leave you. Because we want to send another message to them to reactivate them. We want to know which jokes are most popular. We want to know at what time people are logging into the service. You need all of that. So Beth, she hires a data analyst named Daphne. And Daphne comes with all these questions to Charles. When are most users active, etc., etc. Charles, he says, well, I don't know. I have a spreadsheet. I don't know the answers to these questions. Daphne now goes to Beth and says, Beth, you need to modify this microservice up here so that every time somebody asks for a joke, you also save who it was, what time of day it was, and which joke you sent to them. Now, Beth gets a little nervous here, because you know how it is, right? The microservice, we saw the code for it, it was nice and short. And we all know how it is with code, right? We start writing code, it's nice and short, and then somebody asks us to add something, and add something more, and add something more, and it becomes longer and longer and longer, and eventually you have this monster that you can't debug and nobody dares touch it. Also, what if you add code here to track analytics, and analytics is broken somehow? You renamed a table in the analytics database, for example. Then this could break the microservice so that users aren't getting their jokes when analytics is down. So Beth needs a way to separate out so that analytics won't disturb the main microservice. Also, so that the analytics team can write their code without having a strong dependency on the people writing the microservice code. How can one do that? This happens all the time in companies. You want to decouple systems. So there's one nice way of doing this. You can put a message bus in here. And the message bus that's included in Google Cloud Platform is called Cloud PubSub. And what you do then is, in the microservice, you write some code to publish a message out on the bus. There may or may not be people who listen. Doesn't matter. Then Daphne out here writes code that listens for a particular message. And if that message comes through, Daphne's code is activated. So what's cool with this, by the way, is also when you get other teams involved, there might be a PR team, a marketing team. You may want to insert people in a CMS database. Who knows? They can also listen on the bus. And the microservice here does not need to change, even though you add more functions up here, other teams. So we'll look real quick at the code for that. And so in the reply, we add this one call to publish PubSub message. We can send the joke, and the body here will contain the phone number of the person. Otherwise, it looks the same. And then publish the PubSub message. What you do here is you prepare your data package that goes in the message. You create a PubSub instance, and you create a buffer with that data. This is boilerplate code you would always add, and then you publish it. Here you say what topic it should be sent as, so that whoever's on their side will listen to this topic. This is the code to publish a message. Up here, Daphne has to write code to listen to these messages as they come through asynchronously on the bus. And the way to do that, it's you need to unpack the payload. You need to define the row that you want to insert in BigQuery. BigQuery, by the way, is a analytics big data database that's built into Google Cloud Platform. You need to create a BigQuery object, and boom, this is how you then insert into the BigQuery analytics database. And we're done. So we now have a pretty nice service here. We have a microservice that can listen to SMS messages coming in. It reads in a very scalable way from a scalable database. She has built an admin interface for her content manager, Charles. Plus, up here, she has built an offline analytics database that, even if this one is broken, it won't affect the microservice because it's asynchronous. All of this is a pretty sophisticated system, actually. And all of this, less than 100 lines of JavaScript code. So this is a nice way of building backends. And let's talk real quick about the cost for this. So the SQL database will cost between $8 and $55 per month. If you choose to go with a NoSQL database, you would pay between $0 and $6 per month. So depending on what you're comfortable with. You would also need to pay Twilio to send SMS messages. I have excluded that because I don't work for Twilio, and you need to talk with Twilio and negotiate a price with them. Let's say she gets 1 million hits per month. If she gets 1 million hits per month, she would pay $0 for the cloud functions. She would pay for the database still. But that would actually come in under the free quota. Let's say she gets 2 million hits per month, she would pay like $2 or $3 per month. And if she gets 10 million hits, she would pay something like $22 per month. So this is affordable because this code, you only pay for it when it runs. If you have a server out there that sits there and that is dedicated to you, then it listens all the time, and you pay for it 24/7, even if you don't get any calls. This one you only pay when there is a call. So this is serverless. A lot of companies are using this serverless for various things, like IoT, Internet of Things use cases. Smart parking is using it for that. You have devices out in the field that call your backend all the time, and sensors calling your backend. Very useful to have cloud functions there. You also have Turner Media. They run the website CNN.com. They get, of course, a lot of traffic. So they use this to transmit data, like the log files from all their web servers. They have hundreds of web servers. To transmit the log files into a log consolidation machine where they can see all the log files in one place. So functions are really useful for ETL. And also for voice-activated applications, like you can talk to your phone, right? Okay, Google, and talk to it. For that, I woke up my phone. For that, Cloud Functions is really useful. All right, and now we get to the fun part. I'm going to ask you to do 3 things, all at the same time. But I believe in you. You can do it. I would politely request from you to fill out the survey of this talk, if it was useful or not. I will get good information and good data, and you will be entered in the raffle. And the winner of the raffle will get this Bluetooth speaker. So that was the first thing that I would ask you to do. Second thing, again, it's optional. You probably want to use this amazing service and that Beth built. If you want to send a text message to this number, you're more than happy to have your text messages, and they will come in and you'll get a joke back. Unfortunately, this is a Belgian phone number. Twilio wouldn't sell they were out of Belarusian phone numbers when I tried to buy one yesterday. And that was 2 things. The third thing is, now we have some time for questions. And the first 5 people to ask a question will get a Google Pen that lights up. Look, amazing. And the backend can also be used on your device to like a stylus. And I carried these all the way across the Atlantic, and I'm not carrying them back. Questions? Pens?
Could I ask the question?
There you
thank
go.
you.
Mm-hmm.
I just want to correct the lecture because I seem to found a bug in or misspelling in your code, because when we want to take a random value from array, then we need to divide by modulo of length that array instead of multiplication. Yes?
I don't. We should talk. Let's debug it.
When we random value, then we divide by modulo of length this array, and we take random index of this array. That way.
Let's talk more after this.
Okay.
Because, maybe there's a bug, but it works. Who knows?
Okay.
Thank you very much for pointing that out. 4 more pens. We have the mic person over here. We have. Oh, you have a mic.
Martin.
Oh, excellent.
Thank you very much for a really nice speech.
What color pen?
Like blue one.
He picked a blue one, everybody. The blue pen is gone.
Okay, so my question is about let's assume that the best startup is doing great. And as for our experience with Firebase, when the use cases get more complex, Firebase, in our opinion, gives you more overhead than benefits.
Then what? Pardon?
Benefits.
Then benefits. Okay.
Yeah.
Mm-hmm.
And
like Firebase functions, or
like the platform in general.
the platform. Okay.
Yeah. So and let's assume that for whatever reasons you decide to migrate from Firebase, And do you have any successful use cases for that that you can share? So how can you do that?
Yeah, so for this code here, how can you migrate off of Firebase if you find out that Firebase isn't a good fit after all? So for this code that was written here, that I showed, the server-side code is written as Node.js code, so the Node flavor of JavaScript. So any host that can run Node.js code, you should be able to port this fairly easily too. You can also write these functions in Python if you prefer Python, or if you think that at some day you might want to move to another server side that talks Python. All right, 3 more pens. Do we have a? Where's the mic?
Well, we obviously have some more options to choose from, like Amazon,
Yeah.
Lambdas, at least,
Yep.
Azure,
whatever they call their
functions.
Azure functions.
So
Yeah.
can you please sell it to me? I mean, what is so special what we don't have using Amazon products, Microsoft?
Yeah, good question. So first of all, I haven't used Amazon functions or Azure functions enough to really I haven't used them enough so that I can talk in depth. I did attend another talk in Amsterdam just a few nights ago, where a non-Googler developer who isn't a Googler, he was up on stage and he deployed the same function on Amazon and on Google. And I think he needed he needed a great many configuration files and things like that on Lambda. Again, I don't fully understand it. But on Google Cloud Functions, he needed one function, or one file, index.js. Boom, you're done. You don't need to configure a lot. So he said, again, this is this developer who is a cloud consultant in Amsterdam. He said that he pointed his customers to Google Cloud Functions because there was just less work and less administration. I told him that he should use Amazon's functions because he's a consultant and he charges per hour. So he wants more hours of work, right? But yeah, that's what he said. That's all I know. Yeah.
I have one small question regarding the cold start
Can you send this back?
of Cloud Functions. So how many SMS should I send to hit these functions?
Right. So this is the cold start phenomenon, which is wherever you use Cloud Functions, whatever platform, there will be the very first time. It will take some while to start it up and to load it up on a machine. So the cold start time depends heavily on how many libraries you import. So this here, you saw we imported some Google libraries, we imported some SQL libraries, we imported SMS Twilio libraries. This particular case, when I do cold start for this, it takes 2.4 seconds for the very first one. And then follow on take about 80 milliseconds. Does that answer your question? Yeah. But it depends. If you add like another 10 libraries, it could take a lot longer. So you need to write your functions. Each function is deployed separately. And you need to figure out which libraries do I actually need for this one. Yeah.
Thank you for the speech. I have one question. What are the limits of the one function per function, you know? It's 10 minutes of work of other things. What's the limits?
Yeah, how long can it run for? 9 minutes.
9 minutes.
9
and
minutes.
What's limits of memory, of other things, disk space or other things?
Yep, disk, memory, all that stuff, CPU. All that, when you deploy the function, you can set. So you decide basically that. And 9 minutes, so it's a good idea when you write functions to split up your code into small pieces that can run many pieces in parallel.
Okay, and next question. What is the limit of the message to the class? transfer for the next function step?
The PubSub? Yeah, so when you send a message on the PubSub, on the bus, how big can that message be? This was a tiny message, right? It was only 3 elements. So fortunately, I didn't know this question, but fortunately somebody looked it up for me yesterday, and it's 10 megabytes, I'm told, you're allowed to put in. I'd love to answer all of your questions. Those of you who have other questions or thoughts about whether this is right for you or not, please come and see me later. Look for the pink shirt. But now, we're going to see who walks home with this. And it's not going to be me, because this takes half of my backpack, so I can't fit my clothing if I bring this with. Funk survey? If not, this is your last chance. This, by the way, is just a little thing I wrote in JavaScript. This runs on App Engine. And I wrote it thinking that I would only use it myself, wheelofnames.com. It turns out that lots of teachers are using my app. So I get all these emails where they're asking for features and where they're reporting bugs. So now I fix the bugs in this one. All right. The way this works is it's drum roll. So right hand, left hand, on your knees, and drum roll. And when there's a big enough drum roll, the thing will start. Yes, there we go. Who's gonna win? Victor, Ivan, Dennis, Eugene, Alina. Alina, where's Alina? Oh, good. Oh, I thought you had left. Thank you so much for filling out the survey. Thank you so much for your attention. Love to talk to you later.